Hi guys, let's get started today. So in this unit we're going to be learning how a rate situation can be generalized using many different numbers and how we can put this information in a table. Later we'll graph this information, we'll learn how to solve rate and ratio and proportion problems by using different strategies. We will also see how all of these tables and concepts relate to the multiplication table. So right now I'm looking on page 5 of your activity workbook. If you need to pause this so that you can get it out and work from it, make sure you grab that. Remember, you can pause the video at any time. So we're going to look at these multiplication tables. You guys have seen these before, and we're going to use them again to help us solve problems that have to do with rates and ratios. Now this will probably sound familiar because a lot of you probably did them last year as well, so we should be able to speed through this pretty quickly. So as we look at the multiplication tables, we notice here we have some vocabulary up here at the top, and it's talking about the three things that we're going to be using: factors, products, and factor puzzles. So as you look at the tables, table 1 and table 2, we've got all the factors that are going across in blue, and then more factors that are going down in yellow. That is the same on both of these. And then all these are the answers to those multiplication problems. As you probably already know, those are products. Now, this entire multiplication table is an example of a rate table. You'll notice whether you're looking at the column or the row that they increase by the same amount each time. So if I pick this row right here with your 4 multiplication facts, you notice that each time you move to the right, it is increasing by 4. Same goes true if we go down the 4s column. This is a rate because as you keep on moving down, it's going to constantly add 4. So as we look at the bottom of page 5 in the activity workbook, we'll notice that we've got an example of a multiplication table that is not complete with a lot of the products missing. Now what a factor puzzle is, as you remember from last year, is what we're doing is we are taking part of the of the multiplication table and turning it into a factor puzzle. There are many different ways to solve them, so there's not just one right way to do this, but we'll go over one right now to help refresh your memory. So as we look here, we notice that we have these blue columns, and in the blue column is a 6 and 21. Now one thing you can do is then go back up to the multiplication table and try to find the column that has both 6 and 21. When you do that, you can look through row by row, or maybe you start thinking about factors and multiples and their factors and multiples, and being able to figure out where or which column this is. So if I look here, I notice that 6 and 21 are both in the same column. Now when I think of that, I can definitely go back and look at the full multiplication table, or I can also think about what is the one number that goes into 6 and into 21. Well, if we're not sure, like I said, you can go back up to the table and see that 3 goes into both. We could then label the top of the multiplication in such that way in filling in those blanks right there. So as you've noticed, I've already wrote those down in there to signify that 3 goes into 6 and in 21. You might already know that, or you might need to use the multiplication table. Feel free to write down any of these things, and I suggest writing down everything that I write down so you have a proper example. Now, if you wanted to start with the column, that's great, but you could also start with the row. So if I look at the red row here, this is pulled directly from the multiplication table, and what I'm looking for is one number that goes into both 6 and into 10. Now if you're not sure what it is, again, you can look for the row that has the 6 and the 10 in the same row. So I'll go over here and I'll notice in the 2's row, all the multiples of 2, and here we go, 6 and 10 is there. So that means that 2 goes into both 6 and 2, and then this entire red row would be the 2's multiplication tables. What I've filled out right now, hopefully you did too, makes sense. Just like you've used the multiplication table in the past, we got the 2 row here and the 3 column here. 3 times 2 equals 6. Now our job is to figure out the rest of this blank multiplication table. We'll go over and look at the factor puzzle in a second. If this is getting pretty easy for you and you can figure out what to do next, feel free to speed ahead the video. So this blue column right here, or this blue blank right here, is for this row. And for this column, where it intersects. So now you have to start thinking about your multiplication tables. 2 times what number is going to equal 10? 2 times 5 is 10. So therefore we need to write 5 to label this column, because this entire column signifies that this is the 5's multiplication table. Now there's one other part that I need to figure out, and this would be this red row. Again, we want to fill in what multiplication table is this one looking at. Well, the 3 gives us a guide for the blue column, but now we need the red row. So what we're looking for is 3 times what number is going to equal 21. You could also divide to help figure this out, or maybe you just know your math facts that 3 times 7 is 21. So this entire row goes with the fact that it is the 7 multiplication table. Then lastly, we can look and figure out what that last unknown variable is right here. What amount is missing to fill out the missing part of the multiplication table. This row is the 5 multiplication table, this column is the 5 multiplication table. The 7 is the row. So here we're looking at the product of 5 times 7. 5 times 7 is 35. Now we're not going to use this entire huge multiplication table every time. What we're going to do is we are going to solve these puzzles, and again, most of this is for future work to help us solve rate and ratio problems. We're going to pull out those 4 blocks, the one with the 6, the 10, the 21, and we don't know, and we create a factor puzzle. Notice how the 6 and 10s are lined up with each other because they are on the same row, and the 21 is also lined up with n, what we're trying to figure out. Also, the columns 6 and 21 are lined up exactly like the blue column here, and then the 10 and the unknown amount is also lined up in the same column. Now, to solve these, you can use a multiplication table, or you can use a shorter version, again, if you know your math facts. So if we model what we just did, we started with going across, falling down this column 6 and 21, and trying to find out what multiplication table or factor goes into, or factor of 6 and 21. I'm sorry, let me excuse myself. 3 goes into both 6 and 21. We figured that out. So we could start here, but we can also start here with 6 and 10. So I'll start there just to show you that we're going to get the same answer. So I think about what number goes into both 6 and 10, or what part of the multiplication table is that. If you don't know, look at the multiplication table, but I bet you probably know that 2 goes into both 6 and 10. So therefore, I write it on both sides, 2 here and 2 there. Again, now once you have this written down, there's a lot of places you can go. I'm going to go in this path, but you might find other pathways, but they still should give you the same answer. So 2 times what number is going to give you 6? Well, hopefully you realize that 2 times 3 is going to equal 6. So I wrote those numbers down above and below because that signifies it's the 3's multiplication table. Then I can jump over here, still staying with 2's. 2 times what number is going to equal 10? Or 10 divided by 2 is what? Hopefully you get 5. Sorry for my ugly 5. Now that you have everything filled out, you can fill in the unknowns. So down here we got 3 times some number is going to be 21. Again, use the multiplication table if you need. If not, maybe you just know your facts. 3 times 7 is 21. That means 7 goes here on both sides because that signifies the 7 multiplication tables. Last but not least, I need to figure out the amount for this unknown or empty square. Well, that is going to be the product or the answer to 5 times 7. 5 times 7 is 35. Again, you'll notice that this factor puzzle is just a smaller chunk of what we did with the larger multiplication table. We still have a row, a row with the 2's multiplication tables. We have a 7 multiplication table row, and then we have a column for the 3 multiplication table and the 5 multiplication table in both types of answers. And we have the final product, which is 35. Now as we flip the page to page 6 of your activity workbook, we're just going to do a couple examples. I'll do number 2 and then I'll have you do number 3 by yourself. So either you can work here in the multiplication table, or if you want to work in the factor puzzle, I'm going to kind of use both together side by side. This one I'm going to do a little bit differently. I'm going to start by doing the rows first. So I'm looking to see what number goes into both 6 and to 21. Again, use a multiplication table if you need to. 6 and 21 both have a common factor of 3. So I'll record that on both sides. Again, you decide which one you want to use, but you want to start getting used to using the factor puzzle and the factor puzzle only. So I filled out both sides, but again, I would concentrate or try to become proficient in using the smaller factor puzzle. So now there's a bunch of other ways I could go, but I'm going to show you one way. If you decide on a different way, you should come up with the same answer, so it really doesn't matter. 3 times what number is going to give us 6? Well, I know, either by looking at my multiplication table or just knowing my facts, that 3 times 2 is 6. So 2 must be written as the header for that column. I can then continue and do the same thing. Now, I can go here and decide 3 times what number is 21, or I can go down here and go 2 times some number is going to equal 16. Either way works because you're going to have the same final answer. So 3 times 7 is 21. Again, use a table if you need to. That means 7 goes here and here because that is the 7 multiplication factor. Lastly, I'll go with the 2 and the 16. 2 times 8 is 16 because this whole row is going to signify the 8 multiplication tables. Finally, I got to figure out that last unknown, whether it's here or down here for n. So I have to know the product for 7 times 8. 7 times 8, again, hopefully you know these facts. If not, use that multiplication table. 8 times 7 is 56. So to fill in my answer, I'd put 56 here and 56 on the multiplication table if you so desire. So there's one more example. Now, for table number 5, or for problem number 3 using table number 5, notice that this is a jumbled up multiplication table. It does not go in order, so be careful when you use it. However, it is highlighted. So why don't you take a second and try figuring this one on your own. Okay, so let's just finish this off right here. Again, there's multiple ways you can do that, and I'm only going to do the factor puzzle to show you this one. Okay, so we got one last one that we're going to do together, hopefully have an answer. You could have done it a different way, so don't get discouraged if you don't do it the exact same way. But I'll show you how I would have solved this exact problem. So I'm going to do these rows first because I'm going to try to only focus on doing the factor puzzle. What goes into 35 and 15? Both of those are multiples of 5. This is the 5 multiplication table. Now I can jump here. 5 times what number is going to equal 35? 5 times what number is going to equal 35? That would be 7. So I record that down. And that column is going to be the 7 multiplication tables. I can jump over here now with the 5. 5 times what numbers equal 15? That would be 3. So this entire row, column, is going to be the 3 multiplication tables. Finally, I got 2 more blanks that I got to fill out, so now I can figure out that 3 times what number is going to equal 6. That's going to be 2. That means that whole row is the 2 multiplication tables, 2 on both sides, and finally 7 times 2 is 14. So we're going to end here today. Hopefully this gives you a refresher course in factor puzzles. Hopefully you remembered how to do it. And if not, we're going to work on some more of them tomorrow. See you tomorrow in class. Bye.